Hello everybody, my name is Moufdi Hadjab from Sila University in Algeria. Today, I would like to present my work entitled Revealing the Structural and Optoelectronic Properties of Copper Gallium Oxygen 2 glyphosate oxide based on ab initio calculations. So, our presentation is synthesized according to these points. First of all, we have to start with the preface and the computational detail. After that, we have to show the results of structural, electronic, and optical properties, and finally, conclusion and perspective. As a preface, and as it was mentioned in the literature, the copper gallium oxygen 2 can be used as a layer in the manufacturing in many advanced optoelectronic devices, especially in thin-film solar cells. In the light of the importance of these glyphosate oxides in various optoelectronic applications, our aim in this work was drawn to investigate the structural, electronic, and optical properties such as the lattice parameter, the structure band gap, the density of states, and the rest of linear optical parameters. This structure is shown in figure number 1, which illustrates the crystal structure of the copper gallium oxygen 2 by employing the full potential linearized augmented plane wave method to solve the Konisham equations within the framework of density functional theory DFT using the V2K computational tool. Therefore, for the exchange and correlation, the LDA and the PBU-SOL-GG has been applied to compute the structural and electronic parameters. On the other hand, the linear optical properties has been studied using the semi-Luckelbeck-Jensen potential and its modified version, as well as the parameters of this method as shown in this slide, such as the MTK max, K point, L max, G max, and NMT values for each element. The relaxed equilibrium structure parameters, the calculated lattice constant, the N10 parameter, bulk modulus, and its first derivative were obtained by fitting the total energy versus the volume and the ratio C on E to Monaghan's equation of a state, and with the fourth degree polynomial equation as it is shown in figure number 2 and 3 respectively. Here, this table lists the calculated structure parameters according to LDA and PBU-SOL-GG for the copper gallium oxygen 2, which are in good agreement with theoretical and experimental results obtained under polarization. In this slide, we have calculated the band structure of our glyphosate oxide along various high symmetry directions. In the first Brilliant zone BZ, it's obvious that this oxide is a semiconductor material with an indirect band gap. By the way, the table number 2 summarizes the calculated band gap within LDA, PBU-SOL-GG, and MBG approximations for copper gallium oxygen 2 compared with other previous works. In this slide, we have calculated the T dose and the P dose. Arising the question, what does it mean T dose and P dose? The T dose is the total density of a state, and the P dose is partial density of a state. Of course, within modified Beck-Johnson combined with GG, showing the contributions for each element in T dose and the contribution for each orbitals in the P dose. The optical properties are considered as an important source of information concerning the electronic band structure. It's usually deduced from the dielectric function. Here, we show the various optical parameters shown in these figures, such as the real and imaginary parts of the dielectric function, the reflectivity, the refractive index, the optical conductivity, and finally the absorption coefficient within modified Beck-Johnson potential. Summary: the observed value of the energy gap is much better than the result obtained theoretically. To the best of our knowledge, there is no experimental data concerning this dilaphocytic oxide considered in this study. As well, the values of optical dielectric function, refractive index, reflectivity, and absorption coefficient obtained within modified Beck-Johnson potential show that our dilaphocytic oxide have potential to become an attractive material for solar cell application and advanced optoelectronic devices. As perspective, we need to design, modeling, and simulation and analysis those two structures shown in this slide based on the previous DFT parameters. Finally, thank you so much for your time and attention.